video 3 on sketching quadratics. And in this video we're going to be given a function and we're going to use that function to sketch an accurate quadratic. We're going to talk about the 4 pieces of key information that we can get from a quadratic when we sketch it to show our parabolic form. So here's a quadratic I'm suggesting we use, and I want to sketch this quadratic. There are 4 key pieces of information that we need to find. The first is the Y-intercept, and is typically fairly trivial. So you'll be looking for a nice easy answer there. Usually you can just write it straight down. The second is the X-intercepts, and the third is the turning point. So there will always be one Y-intercept, and there will always be one turning point. But the X-intercepts, there could be between 0 and 2. So you have to be a bit careful there. You might only get 0 X-intercepts, in which case you only have 2 pieces of important information, and the graph might be a little bit less easy to make accurate. And actually, in some special cases, you might get the turning point is also the Y-intercept and there's no X-intercepts, in which case it's harder to sketch again. So you've got to be a bit careful there, but they're generally 4 pieces of key information. So let's find them for this quadratic. First of all, the quadratic's already in standard form, and from standard form we can get the dilation and we can get the Y-intercept. So in this case the Y-intercept is when x equals 0 gives us y is equal to negative 30. So there's a nice piece of information for us. The Y-intercept is negative 30. And let's do the second one. The second one I'll do here. Let's find our turning point. Now remember from the last video, we can find a turning point using 3 different methods. And I'm going to use the one that I think is probably the simplest, and that is that the turning point x value is equal to negative b over 2a. If I had found my x-intercepts, maybe finding the symmetrical point between them would be simpler, but for now I'll use this. Negative b over 2a is negative 4 over 2 times 2, and so that's equal to negative 1. Now the turning point x value is negative 1. The turning point y value is equal to 2 times negative 1 squared plus 4 times negative 1 minus 30, and that of course is 2 minus 4 minus 30, so that's negative 32. And we have a turning point of negative 1 comma negative 32. Now there is a bit of a tendency for your working maybe to end up a bit muddled in this case, and you really should be working in a vertical line, not like what I'm doing, but I'm trying to make this for video. But just do something to make it really obvious where your answers are. That would be a really important thing to do. So there are my 2 answers so far. And lastly, I want to find my x-intercepts. And you know you have the quadratic formula, but let's go through the process of factorizing again, just to help you remind you. So we have 2x squared plus 4x minus 30 is equal to 0. Because to find our x-intercepts, we let y equal 0. Just like to find our y-intercepts, we let x equal 0. Now the first thing I see here is that I can divide through by 2. That's going to help me a bit. I get x squared plus 2x minus 15 equals 0. This has gone from a non-monic to a monic quadratic situation. I want 2 numbers that add to equal 2 and multiply to equal negative 15. And those 2 numbers of course are 5 and negative 3. And so I get x plus 5 and x minus 3 equals 0, and x is equal to negative 5 or 3. And I know the average of negative 5 and 3 is negative 1, which is my turning point x value. So I'm very happy with that. So I might actually write these as coordinates. That means that negative 5, 0 is an x-intercept, and 3, 0 is an x-intercept, and I highlight that so I can see my solutions. Now of course we want to sketch that, so I go down to the sketch that I've pre-prepared, and it's pretty dark so I have to make sure that it stands out. So let's use pink in this case just for video purposes. I know my turning point is at negative 1, negative 32, and my y-intercept is at negative 30. So I need somewhat of a scale here, and I need to be considerate of my scale. So I'm going to go up and down in 5s to make sure that they fit. Now I also know that my And so I'll show this on here. I'll just put -5 there, and I might put one of my values up here as well, 20. That gives me enough of a scale. I know that my x-intercepts go from -5 to 3, so I just have to get down to -5. So I might stretch this out and use the space. Make this 1, 2, 3, 4, 5, and 6. And I might actually just mark my x-intercepts on here. So there's that one, that one, that one, 3. And that way I know exactly what the scale is there as well. So there's my x-intercepts. My y-intercept is at -5, 10, 15, 20, 25, 30 is here. So there's -30. And my turning point is at -1, which is here, -32, which is just there. So I've got key points at here, mark with a cross, here, mark with a cross, here, mark with a cross, here, mark with a cross. And if you're very clever and you actually use the paper, maybe turn it around a bit as you're sketching, you'll be able to draw a much better parabola than I'm currently doing. But you notice here it's not that hard to make it reasonably neat. And I've just done that sitting with the laptop on my lap using a stylus, so I'm sure you can do a very good job of that. Just make sure I label my axes, Y and X, and then you'll probably consider using a graph that's not quite so dark. Just make sure that your information stands out. Your scales are really important, but some people do go a bit overboard writing every number on there, and it's really not that important. As long as I can see what you're going up and down by, then it's fairly reasonable. You do need to make sure that just mathematically you have arrows here and here, you have your labels on there, and that your scale is clear. And if you want to make sure that you get the best possible marks, maybe just put all your important information onto the graph. So -5, 0 over here, 0, -30 to show my y-intercept, and -1, -32 to show my turning point. And so there you have it, sketching a quadratic from a function using the 4 key pieces of information and all those procedures that we've learned in the past. All the best.